Hey there, students. At this point, we are looking at an example of how to use StatCrunch to help us perform a hypothesis test on the mean value for a population. So this is problem number 15 on homework number 11. So this is in chapter 8 from section 3. It says a group of students estimated the length of 1 minute without reference to a watch or clock, and the times in seconds are listed below. And they've got this list here. Use a 0.01 significance level to test the claim that these times are from a population with a mean equal to 60 seconds. So I guess the idea is that if in general people had a pretty good feel of how long a minute is and they were just trying to guess the time without reference, that some might be a little above, some might be a little below, but on average you'd be pretty close to 60. So this is a claim of equality. We're testing the claim that a mean of a population is equal to a number. So when performing a hypothesis test, the null hypothesis is always about equality. So in this case, our claim is the null hypothesis, which is that mu, the mean population, is equal to 60 seconds. And when your claim is the null hypothesis, then the alternate hypothesis will always just be simply that it's not equal to that number. In this case, not equal to 60. So mu equals 60, and the alternate is not equal to 60 is choice D here in this problem. So then it says determine the test statistic. So we are asked to determine a test statistic, and we need to know which distribution to use. We are given the data, so we're going to enter the data into StatCrunch. So I'm going to click on here to open the data in StatCrunch. And now that my data has been listed as a column of values in StatCrunch, we need to figure out which distribution to use. So again, looking at the distributions, we have z-stats, t-stats, proportion stats, and variance stats. Variance stats are for testing standard deviation. Proportion stats are for testing proportions. And z-stats and t-stats are for testing mean values, which is what we're doing here. So the question is, do we want a z or a t distribution? The z distribution is if for some reason you know or have an assumption about the standard deviation for the population. And the t-stat is if you don't have any idea what the standard deviation of the population is. So in this case, they don't tell us anything about the standard deviation of the population. We don't know that. We can't assume that to be anything in particular. So that means we would choose the t distribution, and we would get a test statistic, meaning the t-stat, based on this sample. So I'm going to go to t-stat. We have one sample. Come on here. I'm going to go to t-stat with one sample. And in this case, we have the data instead of a summary. So I click with data. So I choose variable 1 column because that's the column where my data is. Hang on a sec. There it is. Yeah. And then I set up my null hypothesis. So as we did in part A, my mu is 60 seconds, and my alternate hypothesis is that mu is not equal to 60 seconds, and then we compute. So here's the results of our null hypothesis. So the test statistic is the t statistic. Since we used a t distribution, we're supposed to round that to 2 decimals. That's going to be 0.55 to 2 decimals. So then it says determine the p-value. That's also done by StatCrunch, and they want that to 3 decimals. Don't have to round this one off, it looks like. And then we want to state the final conclusion. So here's where our logic about hypothesis testing is getting practiced again and reiterated. So the final conclusion. Well, how do we draw a final conclusion? You can either compare the test statistic to a critical value, but we didn't bother to get the critical value here. Or the other method is to use the p-value, which we do have, and to compare the p-value to the significance level. So we're supposed to have a 1% or 0.01 significance level, and the p-value is like 60%. So it's not even close. In order to reject the null hypothesis that the mean value is 60, we would need to have a probability of getting the results we did that was below 1%, and ours was almost 60%. So we're going to fail to reject the null. So our choice here is to fail to reject the null. And when you fail to reject, that means you didn't have enough evidence to reject it. So we have not sufficient evidence to conclude the original claim that the mean population of estimates is 60 seconds is not correct, meaning there was not sufficient evidence for us to conclude that that 60 seconds is not correct. The null hypothesis claim was 60 seconds, and there was not enough evidence to say that that's not correct. Kind of a double negative there. It appears that as a group, the students are reasonably good at estimating 1 minute. All right, I think that's what they want us. I'll check my answer and find out. I kind of don't like that answer. I think that's what they want, which it is. But the truth is, all we did here was see that on balance, there's a sort of an even distribution above and below a mean value of 60. Does that mean they're good at estimating 1 minute? What if like everybody was either 1 second or 2 minutes? Then the average would be a minute. So anyway, I'm arguing with the book and the problem here. But nonetheless, I could kind of tell what they wanted. They didn't ask us to test that. If we wanted to test whether most guesses were close to a minute, we'd actually probably want to run a standard deviation test as well. If the average was way higher than a minute, that would be an argument against people being able to guess a minute pretty well. But if the standard deviation was also very, very large, that might suggest that their errors were very above and below, but they were so far away from 60 that they're still not very accurate. Anyway, I'll take the point on my homework assignment, and I hope I've helped you guys get that point as well. So keep up the hard work, and I'll see you when I see you.